Okay, Jake, you're asking me about the light sensing circuits, and this is the one I've used in a video before. It's a really basic arrangement with a variable resistor, some two fixed resistors here, a light dependent resistor, an LED, a light
emitting diode.
A light emitting diode, indeed, and a transistor. And the current and the voltage is controlled by this transistor here. And of course, it's sensed by the light is sensed by the LDR, okay, the light dependent resistor. So when this is triggered by light, the electricity or the current flow is increased. It flows to the base of the transistor. The base of the transistor triggers a voltage change from the emitter to the collector and drawing current through the LED and the protective resistor here to allow the LED to run. So it's quite a simple but clever circuit, and the sensitivity of how well this works you can vary by using the variable resistor, okay, or potentiometer, and in this case actually it is approximately 47,000 ohms in resistance. Okay, now the colour code for the resistors we can discuss in the next clip perhaps, but look up the colour code on resistors. It's worth knowing the basics, but if Jake just put hands to here, let's have a look. Brown, black, brown is a 100 ohm resistor. The R is the symbol, well the ohmage is actually is what they mean. R is for ohmage. Brown, black, there's brown, black, red. So that's 100 ohm.
Actually, I think...
Is that the 100? Brown, black, red. Yeah. And the tolerance level, how accurate it is, I think is denoted by that gold or silver line. Is that gold or silver?
It's a gold.
Yeah, so it's I think plus or minus 2%, and it's 5% for silver, I think. So quite interesting for those that are interested in electronics to know some of the basics. Okay, now this is a circuit I'm using with some shed hackers at the moment. This uses what they call a Darlington pair. It's two transistors working together. Very sensitive circuit this, and that is a photo transistor, which a lot of people get confused with a diode, an LED, because it looks similar. There's the LED. I've got a colour changing one on this, and I'll tell you how I know. Within the colour changing LED, you can see the small silicon chip in there. Actually,
and it's a bit cloudy as well.
And deliberately cloudy, and that the reason for that I'll show in a minute, because it's colour changing. And that one says a Darlington pair. Very, very clever little arrangement. There's the sensitivity adjustment you can still have using the potentiometer. It does have a fixed resistor, that's 220 ohms, red, red, brown. Okay, so 2 is red, 2 is red, and brown must be the amount of zeros, and that is 0 in that case. Okay, so yeah, clever circuit this. Yes,
let's see it working.
Oh, one thing before you see it working, I've had to put in a flying lead there because the circuit instructions say with this arrangement for a light dark sensing, we don't put the R3 resistor in, replaced by a flying lead. But quite a clever little circuit. The circuit, just before we go on, they're the actual wires or the tracks underneath the lacquer of the printed circuit board. The green is really the lacquer they put over the top to, in a sense, insulate it. And we've done all the soldering very neatly. It's nice and shiny, and we cut off all the points. And I've put the wires through, so actually when you pull the wire, it doesn't break off the connections here. Okay, the longer leg of the LED is positive. It runs from there to the longer leg that I had soldered on there. Now Jake wants to see this working. I think this is really clever. Look how sensitive this is. So if I put...
So there, can you bring the LED in?
So if I put just the pencil in front of it, the photosensitive transistor, it will turn on. And if I keep it over, it will change colour. Hopefully, any second. Yes, so that's green and blue.
Well, the camera's not really picking up the colour.
Isn't it? Oh, isn't it? Okay.
I don't know why.
Really?
It's not as clear as in real life.
Oh, how strange. Oh, what about from there? No? No, it's just showing. Well, it's colour changing here, but...
We can see it's colour changing. It's just not very...
obvious.
Real, I suppose.
Well, that's really strange. Is that better? No?
That's slightly better, actually.
So that's blue now.
That almost looks like a UV light when it goes blue.
Yes, it does. So this circuit, I do like this circuit, runs on about 5 or 6 volts. 6 volts.
6 volts?
Yeah, 6 volts. And this one runs on...
6 volts again.
But this one is just not very sensitive. Look,
this one.
So look, and I think there may... Oh, yeah. I think this one's actually gone wrong because... Oh, it does go off. Oh,
just about.
That should go clearly off. But I think this needs some adjustment here, Jake, to be honest.
Oh, yeah, it just turned off then.
Yeah.
So there's probably a connection issue down there.
I did have
where
this
that third point goes
possibly
underneath. Yeah.
That used to work quite well, that. I can see I've done some corrective surgery on it there.
Surgery?
Yes, I've added in an extra value. So it worked really well at one point. I think even possibly the transistor has failed. What tends to happen with the what tends to happen with the transistor, and that should go off, you see, they can be overheated and they can burn out with too much current in them. But it could be even a dry joint on one of these connections. Some of these are looking a bit old now, but this one's quite old. Oh, so it does work. You can see it does work.
Not that well.
But just, yeah.
And
yeah, look, you have to really cover it up.
I think it's more to do with connection.
It may well be.
That turns off now.
Ah, yes. Look.
See? So when you're making stuff like this, always check your connections.
Check your connections. Yeah, I think this has got going wrong. But this one's a lovely little circuit, I think. Yes. That works really well. Really sensitive over the photo transistor. And the operation's very... Look how accurate that is. So we're going to be putting these into some of our little projects. And that's the Darlington pair. That's a single transistor circuit. So just trying to just pan over quickly to the circuit diagram. There's the circuit diagram there, showing the various components. Phototransistor, the 1 meg pot potentiometer, and that's the symbol for variable. Transistor 1 and transistor 2, the LED, and the resistor number 3. And it shows an output. It can actually perhaps run a very small motor or even a relay perhaps. Okay, and that's it really. Okay, well, hope you found that informative, guys. And perhaps you'll see this in some of our projects. I know we've done a light sensing circuit on one of our projects, so this will make some sense to you. Okay, I can't get it again.
That was the LED side.
Do you like that, Jake?
Yeah.
Right, okay, see you guys.